Hello, I'm Ed from Humbucker Soup, and this time we're going to learn how to build a single coil pickup from scratch. Building your own guitar pickup can be a very rewarding experience that can be accomplished by almost anyone using items around your house. We discussed the tools we will need in the last video, and if you missed it, I recommend having a look. We'll put the link below. Let's dive right in and get started building our first single coil pickup. The first thing that we need to build is the bobbin. The bobbin is essentially the skeleton of the pickup. There are a few pieces that fit together to create the bobbin. This is what we wrap our coil around, attach our magnets to, and it is the part that actually attaches to the guitar. You can try to find or create a homemade equivalent to the parts we need. Or you can buy each of the parts separately or as a kit from many places online. We will also put a few links below for you to check out. The first part of the bobbin that we need to buy or create is called the flatwork. Flatwork usually looks very similar to the image you're looking at right now. In this image, what we are looking at is actually 3 sets of flatwork. Each color is one set. We only need one set for our pickup. The larger piece is the bottom, and the smaller piece is the top. Looking at this image, we can see the holes that will be used to attach the pickup to the guitar. These will need to be measured to fit your guitar. We can also see 2 metal eyelets where we will attach each end of the coil wire. We will attach the 2 larger conductor lead wires to these same metal posts. The hole that is between the 2 metal posts is where we will pass the 2 conductor lead wire. The smaller center hole in both parts of the flatwork is something specific to this brand of flatwork, and it is not needed in our pickup. If you plan to purchase your parts, it should be fairly easy to find something similar to these. If you want to make these parts by hand, there are many different things that you can use. From a good quality craft popsicle sticks to plexiglass. I made a pickup using a flat wood molding for kitchen cabinets. You will want to use a non-conducting material, and you are going to want to use something that is not going to warp or crack over time. Your flatwork will not need to be shaped exactly the same as store-bought flatwork, but it has to fit into your guitar, so it's going to end up being pretty similar. It's best to try to trace one of your existing pickups and carefully mark the position of each of the holes that you will need. The first 2 holes that we will need to drill are the ones in the bottom section of flatwork that connect the pickup to the guitar. Everything else can be worked around and can give your pickup character, but if these 2 holes are wrong, you won't be able to use the pickup at all. Once you are positive that you have these holes right, it's time to drill the 6 larger holes for the posts in both the top and bottom section of the flatwork. Hopefully you were able to get a good trace. These holes need to line up with each string, or you might not get the best reading for that string. It is important to note that many guitars have a slight taper in the string width from the nut to the bridge. This means that the posts will be slightly closer together on a neck pickup than they will be on the bridge pickup. Another thing that you will want to keep in mind is that the 6 post holes need to be the exact diameter as the posts you will be placing there. There shouldn't be any gaps between the flatwork and the posts when the posts are in place. The next holes we need to drill into the flatwork are the holes for each end of our coil wire and the hole to hold the 2 conductor lead wire in place. A homemade pickup will need to secure both ends of the coil and the 2 conductor lead wire, but the holes do not need to be in the same place as this image. Once we have the mounting holes and the 6 holes for the posts drilled, we will add posts to our bobbin. There are 2 main types of posts that you can use, and your choice will alter your design a little. If you purchase your parts online, then you probably saw the option to purchase Alnico magnet posts. These posts look a lot like the image that you are looking at now. To use these magnets, we are going to push 6 of these into the 6 holes of the top and bottom pieces of the flatwork to form our bobbin. Each magnet should be secure in the flatwork and not fall out or move around. When you are finished, it should look something like the image that you are looking at now. You don't need to worry about the different heights of the magnets in this image because this is your first build. But the taller magnets will be closer to the string and have more output. The height difference of the magnets is called a stagger. You might concern yourself with the stagger of the magnets if you feel a certain string is getting drowned out by the others, or if you feel a certain string is too loud. Another reason is that the strings follow the neck, so a curved neck would have strings at different heights in relation to a flat pickup. The middle strings would be further away than the strings on the ends, so you might choose to stagger your pickup so the magnets for the D and G string are a little taller. If you are making your bobbin by hand, it will be much more likely that you will be using the steel post. The steel post is quite often just a machine screw or something very similar to the image that you're looking at now. But it is possible to buy steel posts that look just like the Alnico magnets in the last part. There are dozens of different kinds of screws that you can use. Every possible length, width, and style of head can be found if you look hard enough. The ones that you will use will depend on your design and what you have available. They need to be steel. You need to fit 6 of them in your bobbin, one directly under each guitar string, and you don't want them to be too long or too short. We will need to stick 1 or more bar magnets on the bottom of the flatwork, and if our posts are too long, they can make the magnets wobble or sit at a wrong angle. Single coil guitar pickups typically range from a little over a ½ inch to a little under 1.5 inches tall, with the majority of them being right around 1 inch tall, including the magnet. A homemade pickup might get a little taller depending on what you use for flat work, but going with a post length of about 3/4 inch should be a good start. You probably want to use the machine screws with a flat bottom and not the type with a point, so that you have more surface for the magnet to stick to. You will want to push the top piece of the flatwork all the way to the top of the steel post and push the bottom piece on so that the end of the posts are just sticking out a little, very similar to the way we did with the Alnico magnets. Once again, this should be a sturdy bobbin with the pieces fitting very tightly together, even surviving a drop without any of the posts falling out. The coil will hold the bobbin together a little, but this is the frame of the pickup and it needs to be secure. You might be able to use some glues or tapes to help keep things tight, but you can't be sure how these things will break down over time and it could affect the pickup. For this fun example though, don't worry about it too much. If you built your bobbin using the steel posts, you will need to use a magnet. You can easily buy your magnets online or at any hardware store. You probably want a bar magnet very similar to the one in this image. These types of magnets can cover all 6 posts with just 1 or 2 magnets. If you do use more than one magnet, make sure that they are all the same type and strength, and that the poles are facing in the same direction when you attach them to the bobbin. I bought several kinds of magnets from the local hardware store that all worked fine. Don't use any kind of magnets that you can bend, like refrigerator magnets. These will probably not be strong enough, and you don't need to use any type of industrial strength magnet. This will probably be too strong. One thing to remember is that you want a bar magnet with the poles lined up like this image. In this image, the top half of the magnet is north, and the bottom half of the magnet is south. This would result in a bobbin with all 6 posts having the same magnetic charge. In this next image, we will see a very similar bar magnet, but in this type, the left side of the magnet is north, while the right side is south. This would result in a bobbin that would have 3 posts with a north charge and 3 posts with a south. We want all of our posts to have the same charge. Once we have chosen the magnet or magnets that we will use, I recommend sticking it to the bottom of the bobbin and then testing the whole bobbin in your guitar to make sure it will fit. This is much less necessary if you have ordered the parts online, but you might want to check the string taper we talked about earlier. Once you are satisfied with your design, your bobbin is finished and it's time to start winding your coil. In the space between the top piece of flatwork and the bottom piece is where we will wind our coil. We begin by winding the end of our wire through one of the eyelets in the bottom piece of the flatwork. Or if your design uses metal tabs, you should be able to wind the wire around that a few times. You will want the wire to be secure while you wind, and when you solder the lead wire on later. Before you can wind the wire though, you will need to remove the coating from the wire. If you are using enamel-coated wire, you will need to scrape the enamel off with a screwdriver or knife. If you are using a poly-coated wire, you can melt it off easily with a soldering iron. If you are using a variable temp soldering iron, be sure to use the lowest heat setting. Once the coating has been removed, you can wrap the wire and solder it in place. Now we can begin to wind our coil. Try to wind the coil evenly between the top and bottom sections of flatwork. Try not to pull the wire too tight, but don't let it be too loose either. You will want to wind a considerable amount of wire around the bobbin, as much as you can wind before the wire begins to bulge beyond the flatwork. Once you feel that you have enough wire wrapped around the bobbin, you can break the wire from the spool. Remove the coating from the last inch or so and wrap it around the other eyelet and solder it in place. Once this is done, you can check to see if the pickups work by using your multimeter. You do this by setting your meter to ohms. If there are multiple ohms setting on your meter, choose the one closest to 20,000. Touch the black lead wire to one eyelet and touch the red lead to the other eyelet. If you get a reading, then your pickup works. Once you have confirmed that the pickup works, it will be time to connect the lead wires. The lead wires are the two wires that you will use to connect the pickup to your guitar. To connect the lead wires, simply solder one wire to one eyelet and one wire to the other. If you are using two-conductor shielded wire, the third bare wire is the shield and will be soldered to the ground in your guitar. Once the lead wires have been attached, your pickup should look similar to this image. You should test the ends of the lead wires with your multimeter again and make sure that the pickup still works. The final step in our pickup building process is the wax potting. To wax pot our pickup, we will need to submerge it in melted paraffin wax for at least 20 minutes. If you are using bar magnets, I recommend removing them for the wax potting process. Be sure that you melt the wax safely and keep the pickup submerged until you no longer see any bubbles. Remove the pickup from the wax and let it cool for a few hours. Test it one more time with your multimeter. If it still works, install it into your guitar and have a listen. Congratulations on completing your first guitar pickup. I hope that it sounds great. Next time we will take a look at the double coil or humbucker design. See you then.